Hello students, welcome back to my YouTube channel Data Sharp. In today's lecture, I'm talking about full pivoting questions in the Gauss elimination method. So we have discussed what is pivoting, what is partial pivoting. Now we come to the second type of pivoting, that is full pivoting. So what is pivoting? It is the process in which we are talking about the interchanging of the rows so that we could find the best pivot element. Okay, and the best pivot element means that if a row is having 0 as the pivot element, you can just interchange that. Now the partial pivoting is related to column wise. So in each column you are finding out the um, element with the maximum magnitude, right? But in the full pivoting, what we would be doing, we'll be searching the element with the largest magnitude in the whole matrix. So that's why it is called a full pivoting thing. It is very confusing sometimes, but um, obviously you are getting less round of errors, but still we avoid full pivoting because it involves a great deal of data movement and it is very, very complex. So, but if you get a question that you have to do it with full pivoting, you have no other choice. But if you are solving a Gauss elimination method, I mean, solving the equations using Gauss elimination, then try to prefer doing it with partial pivoting and not with full pivoting because it's very, very complex. But yes, it has an advantage over the partial pivoting. You will get more accurate answer in the full pivoting, and that is it would be less prone to the round of errors. So generally partial pivoting is not that's why the partial pivoting is preferred during I mean over the full pivoting because it is very complex. Full pivoting is very complex. So now let us I'll just tell you in this we search for the element with the largest magnitude in the whole matrix. So that becomes your pivot element. So that becomes the pivot element. So every time when you need to perform the Gauss elimination method and you have to select the pivot element, you have to use this approach every time. So let us consider one question where solve the linear equations using Gauss elimination with full pivoting. So let us consider the system. So I'll explain you how it becomes complex when we are talking about this. So let's see here. Here the I can rewrite this as AX is equal to B. That's 132, 131, 143. X is X1, X2, X3. The BIs are 6, 20, and 30. Now, here the augmented matrix is given by now according to the full pivoting, what we have to do, we have to search for the element with the largest magnitude in the whole matrix. Now, which matrix we are talking about? We are talking about these. Okay, so I'm talking about this only, right? These elements only. So you need to understand that this. Now, in this whole matrix, which element is of maximum magnitude? This element that you could see, this is of maximum magnitude. Earlier, what we were doing, we were just interchanging the rows. Now we'll be interchanging the columns also. And when you will interchange the columns, you need to understand that your variables would also be changing, because right now, what you have, I'll be writing every time this. This is x1 column, this is x2, and this is x3, right? Because these are the coefficients of x1. You can see 1, 3, 2. Coefficients of x2, 1, 3, 1. Coefficients of x3, 1, 4, 3. But when you will be interchanging this, then your variables placement would also be changing. So that's why it is very complex. Now, let's see. Let me take another page. Now, what I'll be doing? I'll be taking this element to this position, A11. Right now, it is lying here at the A23. This is the A23 element. I want to shift it to A11. How could I do that? First, I'll interchange the row 2 with row 1. So what I'll be getting here. So let me just divide this uh, page into two portions, so that okay. Okay, so R2 is interchanged with R1. So I am getting this as 3, 3, 4, 26, 13. This is 1, 1, 1, 2, 1, 3. Now I'll be shifting it to the this one. So interchanging the columns. So column 3 is changed with column 1. So now it would be 4, 1, 3, 3, 1, 1, 3, 1, 2, 26, 13. Please notice there is no change in this. Now, what is this? This is my x3 variables. This is my x2, sorry, this is my x3 coefficients. This is my x2 coefficients. This is my x1 coefficients. So every time you need to understand this, and then you will be moving ahead. Now, this is my pivot. So take A11 as pivot, and you make these two zeros and make A21 and A31 as 0. So the elementary row operations, as I have explained how to find out the elementary row operations. So it would be row 2 minus A21, that is 1 upon the pivot element, row 1. And row 3 would be row 3 minus 3 upon 4, row 1. Now, when we'll apply this, I'll be getting first row remains unchanged. So there is no change in that. This is 0, this is 0. So what are the other elements that I'll be getting here? We could subtract this. This would be 1 minus 3 upon 4. So this becomes, this becomes, let me just take this. Yeah, 1 minus 3. So this is 1 upon 4. And this would be again 1 minus 3 upon 4. This is 1 upon 4. This is 6 minus 20 upon 4. So that's 5. So 6 minus 5 is 1. Now, for this, I'll be 1 minus 3 upon 4 into 3. So that's 4 minus 9 upon 4 minus 5 upon 4. And this would be 2 minus this. So 8 minus 9 upon 4 is minus 1 upon 4. Then lastly, this would be 13 minus 3.4 into 20. So that's 5. 13 minus 15 is minus 2. So this is how I'll get the elements. I'll just erase this, okay? Now, this part is done. What is the next step? Now, you will not be considering these elements, I'll just mark it. Delete the first row and the first column because you are searching for the element of maximum magnitude in this matrix now. So in out of these four elements, which is the element which is of maximum magnitude? So this is 1 upon 4, 1 upon 4 minus 5 upon 4 would be absolute value of minus 5 upon 4, right? So this is of maximum magnitude as we could see. So what we have to do, we have to just shift it to the A22 position. Okay. So let me just delete all of this. And this is my x3, x2 and x1 because we'll be changing the positions. If the columns are not changing, now the rows are only interchanging. So that's not a problem. Now, this is of maximum magnitude, right? So I'll be shifting it to the row 3 is interchanged with row 2. So I will get here 4, 3, 3, 0, minus 5 by 4. This is what we are getting. Now, this is my pivot. So I'll take this as my pivot element. Take A22 as pivot and make A32 equal to 0. This is what you have to do. So what would be the elementary row operations that you will be performing? My elementary row operations would be on row 3. So row 3 goes to row 3 minus A32 upon A2 to R2. So this is nothing but A32 is 1 upon 4 upon A22 is minus 5 upon 4 into R2. So when you will cancel this, what I am getting this as plus 1 upon 5. So I'll just write this as plus 1 upon 5 times R2. So when I'll apply this elementary row operation, I am getting this as 4, 0, 0, 3 minus 5 upon 4, 3 minus 1 upon 4, 20 minus 2. This becomes 0. Now, about this is 1 upon 4 plus 1 upon 5 minus 1 upon 4. So as we could see, this becomes 5 minus 1 upon 20. So what I'm getting in the last would be 4 upon 20. So that's 1 upon 5. And for this particular, this is 1 plus 1 upon 5 minus 2. So that's 5 minus 2, that is 3 upon 5. So this is easy enough, right, to understand. And what are the values that I was getting here? This is x3, x2, x1. I'll be writing this again, x3, x2, x1. Because this is important because now I'll be applying the backward substitution because forward elimination is done. And I can rewrite this as this is x1, x2, x3 and 20 minus 2, 3 by 5. So when we'll be applying the backward substitution, I'll be getting here 0x, 0y, 0z, sorry, not 0. This is 1 upon 5z. So x1 plus 0, x2 plus 1 upon 5, x3. We generally have x, y, z, so I was into that notion only. So this is 3 upon 5. So ultimately, I'm getting my x3 as 3. Then 0x1 minus 5 upon 4x2 minus 1 upon 4x3 equal to minus 2. Am I doing it in a correct way? No. This is wrong. This is wrong. Why this is wrong? Because what we need to understand, this is the normal behavior that we were doing in our previous cases. Why I have written this here, x3, x2, x1? Because they have changed their positions. So whatever I have written there here is incorrect. Okay. Now 400 is the coefficients of x3. So this would be of x3. This is x2 and this is x1. This is the correct way. So don't do it in the same fashion that we were doing for the partial pivoting or the Gauss elimination method, because this is full pivoting and you have to be very, very attentive while performing these final step, right? The second and the final step of backward substitution. So I'll just erase this part quickly. I hope this would be clear for everyone why I am doing this. Okay, so now when I'll be applying the backward substitution, I'll be getting this as 0x3 plus 0x2, 1 upon 5 x1 is equal to 3 upon 5. So my x1 is coming out to be 3. Okay, so this is 3. Now 0x3 minus 5 upon 4 x2 minus 1 upon 4 x1 is equal to minus 2. When you will solve this, I am getting x2 as 1. Similarly, 4x3 plus 3x2 plus 3x1 equal to 20. I'll get my x3, sorry, as 2. Thus, the solution is capital X, that is 3, 1, 2. So this is my final answer. Using full pivoting, how I can find the solution of the system of equations. So Gauss elimination with full pivoting will give you this. So using backward substitution, when you are applying, here I am applying the backward substitution. This step is very, very important. So we'll meet again and in the next lecture where I'll be talking about the another direct method, that is Gauss-Jordan. So I have covered 3 lectures in for the Gauss elimination method where I have explained partial pivoting, full pivoting and the Gauss elimination method. So we'll meet again next. Thank you so much.